Find all real solutions of the equation. Enter your answers as a comma-separated list. The equation is x to the 1/2 power plus 7 times x to the negative 1/2 power equals 8 times x to the negative 3/2 power. First thing that we're going to do is put everything all on the same side of the equal sign and make this be set equal to 0. And so I will have x to the 1/2 plus 7x to the negative 1/2 minus 8x to the negative 3/2 is equal to 0. The next thing I'm going to do is rewrite the variable expressions that have negative exponents using positive exponents. So the first one doesn't change, but this becomes 7 over x to the 1/2 power minus 8 over x to the 3/2 power, and that's equal to 0. Now what I want to do is, since these are rational expressions, is go ahead and multiply through by the highest power of x in order to eliminate the denominators. And in this case, the highest power of x is 3/2. So that means when I multiply through by x to the 3/2, I'm going to be changing the exponents as I go through. So if we have x to the 1/2 power plus 7 over x to the 1/2 power minus 8 over x to the 3/2 power equals 0, and I multiply through by x to the 3/2 power, I will use the distributive property of multiplication over addition. This first one, x to the 3/2 times x to the 1/2. And I'm going to go ahead and write out each individual multiplication so that we can look at what happens with the exponents. So this will be x to the 3/2 times x to the 1/2. Then I'm going to have this plus sign right here, and I'll go ahead and multiply x to the 3/2 power times 7 over x to the 1/2 power. So I have x to the 3/2 power times 7 over x to the 1/2 power. And then I have this negative sign, so we have a subtraction. And now I'm going to take and I'm going to multiply x to the 3/2 power by 8 over x to the 3/2 power. And that is going to simply be equal to 0. Now let's look at the first expression. X to the 3/2 times x to the 1/2. These are like bases, so I'm going to add the exponents. 3/2 plus 1/2 is going to give me 4/2, but I'm going to go ahead and write out as x to the 3/2 plus 1/2, and then I'll write it as x to the 4 over 2 power, or 4/2 power. Now, I can go ahead and simplify that and simply have x squared. The next thing that we're going to do is we're going to look at x to the 3/2 times 7 over x to the 1/2 power. Now, remember that when I go ahead and combine these, since I have an exponent in the numerator and an exponent in the denominator, and they are like bases, I will subtract the exponents. So this is going to give me 7 times x to the 3 over 2, or 3/2 power, minus 1/2. That's going to be 7 over x to the 2 over 2 power. I mean, not 7 over x, but 7 times x raised to the 2/2 power. But that simplifies into simply 7x. Then we'll have a subtraction here. And once again, we're going to do a subtraction of the exponents. Like bases, I subtract the exponents if one is in the numerator, one's in the denominator. And so this simply becomes 8 times x to the 3/2 power minus 3/2 power. And this is simply going to be minus 8x to the 0 power, because 3/2 minus 3/2 is going to give me x to the 0 power. So this is 8 times x to the 0 power, but we know that x to the 0 power is 1. So 1 times 8, and I simply end up with minus 8. Don't forget that the whole time this has been equal to 0. Now, one thing that you have to remember is once we solve this, we need to verify that the answer that we get, or the solutions that we get, work in the original equation, because we have multiplied by a variable. Once you do that, or if you divide by a variable, you run the risk of introducing extraneous roots. Yes, we can get an answer, but that doesn't mean that it's necessarily going to solve the problem. So now we look at x squared plus 7x minus 8 equals 0, and we see that this factors. We're going to go ahead and factor this as x plus 8 times x minus 1, and that's going to be equal to 0. Using the zero product principle, we'll split this up into x plus 8 equals 0 and x minus 1 equals 0. Therefore, x is equal to negative 8, or x is equal to 1. Once again, you need to check to see if either one of these does not work. So you would go back up to your original equation, which was, as we wrote, x to the 1/2 plus 7x to the negative 1/2 equals 8x to the negative 3/2 power. And then you're going to substitute in negative 8 and 1. Now, one of the things that you're going to see is the moment you put negative 8 into this thing, if I put it into just this one, I don't even have to look at the other two. But this becomes negative 8 to the 1/2 power, which means it's the square root of negative 8, which is imaginary. Or not real. Therefore, negative 8 can't be a solution. And if I plug 1 into this thing, I'll get 1 plus 7 equals 8, because the 1 to the 1/2 power is 1. 7 times 1 to the negative 1/2 power is going to be 7 over 1. And that's going to be 7, and then that's going to be equal to 8 times 1 to the negative 3/2 power, which is 8 over 1 to the 3/2, which is also 1. So I end up, simply stated, with 1 to the 1/2 power plus 7 over 1 to the 1/2 power is equal to 8 over 1 to the 3/2 power, which means I have 1 plus 7 equals 8. 8 is equal to 8. That checks. That means that the solution is x equals 1.